everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video, we're going to talk about the law of sines. This is a part 2. This is a continuation video, so if you want to check out part 1, click right up there. So in the last video, in part 1, I introduced the law of sines and we did some examples, but these examples were of this case 1, this first case where we're given one side and two angles. So this tends to be the more, straightforward case with the law of sines. We're using the law of sines. We're given one side, we're given two angles. We can find that third angle right off the bat because all three angles have to add up to 180. So we can find that third angle. Then we use the law of sines to find the remaining sides. So this is the ASA or SAA, or you can even flip this and write AAS. It doesn't matter to me, the order. So yeah, this is the more straightforward case. Case 2, which is what this video is going to talk about. Case 2, this is by far the trickiest part of law of sines and just of solving triangles in general. This case 2, also known as the ambiguous case, right? And this is where we could potentially have no triangle, one triangle, or two triangles, all right? And that's what makes this so tricky, is that we have to do some investigating to find out which of these possibilities we're gonna have. So again, case 2, we're given two sides and the angle opposite of one of those sides. That's what we're given. So SSA, you could even flip it and write ASS if you want to write ass on your paper. That's fine with me. And that it might even be a good way to remember. If you're ever like, man, is this the case where I could potentially have two triangles? Just think, is it the ass case? And if it is, you could have two triangles with the ass case. So maybe that helps you to remember. But anyway, we're given two sides and the angle opposite one of them. So I could be given side A, side B, and then either angle A or angle B. If I'm given angle C, then I can't properly use the law of sines because I have to compare two of these, right? And that would actually be law of cosines in my next video. So that's the case with law of cosines. But anyway, we're given two sides, we're given the angle opposite one of them. So let's suppose sides A and B and angle B are given. So if you're a visual learner, maybe this explanation can help you looking at these, and maybe you can understand, oh, this is why we have these three possibilities for this. But let's go and look. Again, we're given angle B, side A, side B. And I could change this to angle A if I want. It would literally just be this mirrored. It doesn't matter. So again, this is the SSA or the ass case or whatever you want to call it. I have the angle, side, side, right? So again, what I'm given I cannot change. So this angle B is fixed. This length, this side length, A, is fixed, and so is this side B. But what I can change is I can change this angle in here. I guess that would be angle C, because this would be side C. Right? So maybe I'll write that here. I have side C. This would be angle C, not angle B, angle C. Okay? And then this would be angle A. So those three things can change. So in the case of no triangle, this is the case where the length B I'm given is not long enough, right? You can imagine swiveling this, because again, my angle C can be whatever I want, whatever works. But imagine swiveling this and then extending and contracting this side C, and they just can't meet no matter what I do. So that's the no triangle case, right? They just can't meet. One triangle is, imagine swiveling this B and extending and contracting the C, and they pop right into place perfectly to form one triangle, all right? So that's the case of one triangle. That's how that happens. With two triangles, what happens here is I can swivel B, and I can basically have that length of B that's given, and I can make it work with two different triangles, right? Because I can swivel and I can meet up with a shorter length side C, but then I can swivel it further out and extend my side C and meet up again. I can form two different triangles. So that's why we have these three possibilities with this ambiguous case, and that's why they call it the ambiguous case, because we are unsure of which of these three possibilities we will have, and we have to do some investigating in order to find out. You can't just look at a problem, look at the numbers given, and be like, oh, that's one triangle, right? You have to do some investigating. So we're going to go ahead and look at plenty of examples, but hopefully this helps at least understand why we have these three possibilities. All right, so let's go and jump into an example. We are given side A, side C, and angle C. So as we can see, this is a side-side angle case, so this is the ambiguous case. So since it's the ambiguous case, remember I said we had to do some investigating. So I'm going to hold off on drawing my triangle, on drawing the picture, because I don't know if this is no triangle, one triangle, or two triangles, right? So what I mean by do some investigating is we just jump straight into the law of sines, right? I have side C and angle C, so I can compare side C and angle C to side A and angle A. So basically I'm going to solve for angle A. So I have sine of 50 degrees over 1 equals, right, that's sine of C over side C equals sine of angle A, right, sine of A over 2. So I'm just using the law of sines here. Here I'm going to quickly, let's see, I could cross multiply. I could think of it that way, or I could just multiply both sides by 2 since this is over 1. Either way, so let's see, if I cross multiply, I get sine A equals 2 times sine of 50 degrees. So I'm going to go ahead and punch in 2 times sine of 50 degrees into my calculator. What did I get? I got 1.53. So I punched this in, I got 1.53. So normally I'd write out sine A equals 1.53, and I'd take the inverse, the sine inverse of both sides to solve for angle A. But what do you notice here? We have 1.53. Sine of an angle is 1.53. That doesn't make sense, right? Because the range of sine is from -1 to 1. So when you run across something like this, and you could punch this in a calculator, take sine inverse of both sides, but your calculator will give you an error, right? Because this is actually not possible. You cannot get 1.53 from sine of any angle. So this is the case of no triangle. We have no triangle. And this is what you'll run into when you have, let's see, can I spell triangle? This is the problem you'll run into when you have this possibility of no triangle, is you'll come across something like this where it's like sine A equals 1.53. It could, maybe it's sine C equals -2, something like that where it's just not possible. Then you know we have no triangle. So I actually don't have to continue from here. I can write no triangle and we're good to go. All right, so here's our next example. We're given side A, side B, and angle A. And again, what we're doing with these examples is we're solving these triangles. So what we're being asked to do is, given this information, basically fill in the blanks, right? I'm trying to find this side C and this angle B and angle C that work with this given information to form a triangle. And if I have the possibility, right, that case where we have 2 triangles, then I have 2 different sets of information that's going to be in my solution. I'm going to have 2 different side C's and 2 different angle B and angle C's, okay? And if there's no triangle, then I just write no triangle. It's no big deal. So let's go and get into solving this. And again, the first thing we do, we just jump straight into the law of sines. So I'm going to write sine 38 over 4. Sine 38 degrees over 4 is equal to sine of B. I'm solving for angle B over 6. All right? First thing I always do, so cross multiply. I'm going to have 6 times sine 38. 6 times sine 38 degrees equals 4 times sine of B. All right? So again, I want to isolate sine B so I can take inverse of both sides so I can solve for angle B. So what I'm going to do here is divide both sides by 4. Divide both sides by 4. That's going to isolate my sine B. These 4's will cancel. So now I have sine B equals 6 times sine 38 all over 4. 6 sine 38 degrees over 4. So again, the first thing I want to do is punch this in a calculator and make sure it's between -1 and 1. If it's not, bam, no triangle and I'm done. All right? So let's see. If I punch this in a calculator, I get 0.92349, etc. So it is between -1 and 1. So I can eliminate the possibility of having no triangle. We definitely have one triangle. All right? So now what I do, now that I know this is going to work, I take the sine inverse of both sides. So taking the sine inverse of both sides, what happens is I come in here and I do this, sine inverse, and those cancel, right? So I'm left with, let me draw an arrow here, and what this leads to is angle B equals, and since I'm taking sine inverse of both sides, I do sine inverse of this whole thing as well. So angle B equals sine inverse of 6 times sine 38 degrees over 4. So this is what I punch in the calculator, and I get 67.442. I'll round 1 decimal place, so 67.4. So I have B, angle B equals 67.4 degrees, okay? And now here's the key. We know we have one triangle. We know this is the angle B that works with one triangle. How do we know if we have a second triangle? And this is where you always have to check. You always have to check. Anytime you have one triangle, you have to check immediately to see if you have a second triangle. That's the only way to find out, is to check. So let's think about this. What happened here when we took the sine inverse of both sides? And now we have to go all the way back to a few chapters ago when we talked about the range of sine inverse. So the range of sine inverse is from negative pi over 2 to pi over 2. If I write it in degrees, it's from negative 90 degrees to 90 degrees. All right, we have 0 here. Since we're dealing with triangles in this case, we're not going to have negative angles. So really, anything I punch into my calculator to find the angle of using the law of sines with this SSA case is going to be an angle between 0 and 90. All right, but what if an angle that works is between 90 and 180, right? That's a possibility. All three angles on my triangle have to add up to 180. But that means I could still have a 120 degree angle or something like that that works, right? So how do I find out? Because again, I'm limited to this range with using sine inverse. So that's what I have to come in here and do is find out if there's an angle that works that is in this second quadrant. So let's see how this works. So 67.4, that's about here. Oh, that's terrible, sorry. That's about here, all right? So that's this angle here, 67.4 degrees. So basically what I want to do is I want to use this as a reference angle and find out, right? Because again, sine is positive in the first and second quadrant. So using this as a reference angle and drawing it this way, I want to find out if there's a value in the second quadrant, right? An angle in the second quadrant. So really it's going to be this angle here. If this angle works for this triangle, right? Because again, look what I have here. Sine B equals this value. Remember when we were solving things like sine B equals, or sine theta equals root 3 over 2, we were solving things like that from the interval 0 to 2 pi. We would have two solutions because sine is positive in two quadrants. That's kind of the same idea here. I'm just trying to make all these connections. And if that's not making sense, then I apologize. But really what we're going to do is we're looking to find this angle here, right, using this 67.4 as a reference angle and see if it works with our triangle. What I mean by does it work? Well, if we add this angle to it, is it still less than 180? So let's go ahead and start and see how this works. So again, I'm looking for this angle, so I can do 180 minus this reference angle to get the angle I'm looking for. So 180 minus 67.4. And in general, this is always what you'll do. You'll take 180 and you'll subtract what angle you found. All right. So let's see if I can do some quick mental maths here. 112.6, hopefully that's correct. 112.6, that looks good. So let's see, if I go back and add it to A, I'm still less than 180. So I have basically room for an angle C, a third angle, right? I have room. So that means that we do have two triangles in this case. There's two angle B's that work. We have B equals 67.4 degrees, and you also have B equals 112.6. So maybe I'll label this B1 and B2 equals 112.6 degrees, all right? So now what I need to do is I need to go find angle C that goes with this first triangle and then angle C that goes with the second triangle, because clearly they're going to be different angles. They have to add up to 180. Clearly they're going to be different. And then I can go and find the side C, and those sides are going to be different as well. So let me see if I can erase and make some room for that. All right, so I've organized this nicely where I have triangle 1, triangle 2, and I have the angle B's that work for triangle 1 and triangle 2. So I'm basically filling in the blanks here. I'm going to fill in both these angle C's and both the side C's, and then I'm done. I'll have my two triangles solved for. Okay, so I'm going to start with this triangle 1. I have angle C. How can I find that? Well, again, all three of my angles have to add up to 180. So if I do 180 minus 38 degrees minus 67.4, I should get my angle C because they all have to add up to 180. And what do I get? 74.6. 74.6. So I can go ahead and fill that in here. My angle C is 74.6 degrees, and they should all three add up to 180, which they do, so I'm good. So how can I find my side C? Well, now I can use law of sines again. So now that I have angle C, I can use angle C to basically compare with, well, I'll go ahead and show you. Sine, I could use B or A for this case, so I'm going to use A. Sine 38 degrees over 4 equals, right, now I can use this angle C to find my side C. Sine of 74.6 degrees. 74.6 degrees over C. So one thing you can actually do is you can flip both of these. If you have a fraction equals a fraction and you flip both sides, it's still equivalent. So you could flip both and then just multiply both sides. or you could think of cross multiplying if you prefer that. I'll go ahead and do that method. So 4 times sine of 74.6 degrees equals C times sine 38 degrees. So now basically I divide both sides by sine 38 because I want to find C. And this is nice because I don't have to use inverse at all. I don't have to worry about any of that stuff. So I can just cancel. Now I have C equals 4 times sine 74.6 over sine 38 degrees. Let me see if I can find that. All right, so I got 6.26. I'm rounding to 1 decimal place, so I'll round to 6.3. And that just depends on the instructions. If it says round to 2, then round to 2. I'm rounding to 1. So I have my first triangle now. I have my first triangle done. So let me go ahead and move on to my second triangle. The process is exactly the same though. So again, 180 minus angle B minus angle A. That's going to give me angle C. And angle C is clearly going to be a lot smaller than this first triangle, right? 180 minus 38 minus 112.6. Wonder if I can do this in my head. 38, that gives me 156. So I think this equals 29.4. Let me fact check that. 29.4, nice, quick maths. 29.4 degrees. Now I can find my side C using, again, law of sine. So I'm going to use that sine 38 over 4. All right, that's sine A over A equals, now I'm going to use this angle C. Sine 29.4 degrees over, I guess I technically should keep the degrees, I guess, over C. So again, when I cross multiply, bam, bam, I get 4 times sine of 29, that's an ugly 9, sorry about that, 0.4 degrees equals C times sine 38. And again, I'm going to end up dividing both sides by 38. Maybe you can do this quicker than me. That'd be awesome. If you have a better way, do it that way. Sine 38 degrees. I'm just doing it the way that I think is most familiar to everybody. I think mostly everybody uses cross multiplication, so that's why I'm doing that. C equals this whole guy. So now I can punch this in a calculator. So I have side C is 3.2. So side C is 3.2. And now I've done, I have found triangle 1 and triangle 2. So let's go ahead and summarize this. Whenever you're given a side-side angle, you're going to know immediately it's an ambiguous case because you're going to think, oh wait, this is the ass case, right? Haha, ambiguous case. I may have no triangle, 1 triangle, or 2 triangles. So you're going to go ahead and go straight into using the law of sines. If you get something that doesn't even work, that's undefined, like sine A equals 2.5 or something crazy, no triangle. Move on. You're good to go. If you get 1 triangle, right, if you get something that works, you find that angle, and then you got to check and see if there's a second triangle. You always check. And if you add it back to that first angle, right, when you find that second angle using that reference angle, basically 180 minus the angle you found, right? So you find that second angle. If you add it back to the original and it spills over 180, then you know a second triangle cannot be formed. If it stays under 180, then you know, hey, I have room to form a second triangle. I do have 2 triangles. And if you have the 1 triangle, then just solve your 1 triangle. So if you have 2, then solve both. Hopefully this video helps. I know it's a little overwhelming. I'm sorry. I will make another video on this. I will give another example. So stay tuned for that. But until then, keep flexing those brain muscles. Check out my channel if you need more help. Leave any questions below in the comments. I'm happy to answer questions, and I'll see you on the next video.